module, we will be specifically looking at the different types of compression or archiving tools that are actually available on the Linux system. So, what is exactly compression or archiving and why is it so important for us to understand? So, when we actually have a data file, if the size of the data file is pretty small, we generally would not be too much concerned about the fact that the size is small, because it is not really going to be consuming too much of disk space for us. But when we actually deal with files that are running into let us say megabytes or gigabytes of data, then there will be situations where unless and until we sort of compress the data and get a compressed file, we would not be very comfortable with actually having that particular huge file occupying so much of our disk space. So, for that simple reason, you have different kind of compression and archiving mechanisms possible in the Linux system, and we will see in this particular module what the different kinds of tools are, how do they really work, and what are the benefits associated with them. So, before we actually go ahead and try to run any of these compression tools, one of the first things that we need to understand is we will have to first get an idea of how much of disk space is actually used by certain files, and once the file sizes cross a certain threshold, then we would possibly be deciding that we need to go ahead and apply the compression tool on that file so as to make it occupy much lesser space. Now, there is a command called du which basically helps us to understand how much of disk size is being used by a single file or a set of files put together. So, if you really try to run -h option with the du command and give the file name also for which you would for which you are interested to know how much size is being occupied, it will basically report to you what is the size of the file either in kilobytes or megabytes or gigabytes, so that it basically it becomes very easier for us to quickly understand how much is the size of the file rather than printing it in a normal bytes format. So, if we do not use the -h option, the du command will return the raw number of disk blocks that this file is using, and because of the fact that it is giving the number for the size in terms of the disk blocks, we need to also know what is the disk block size for us to understand exactly how much of bytes that file is occupying. So, in that respect it is little bit hard to read. So, typically you will find the administrators or the users who want to use the du command always use this command with the -h option, so that the file size or the directory size, whatever is being looked at, basically becomes easier and human readable very quickly. So, if you also use the -h option, it displays the sum of the disk usage of all the files in the given directory. So, that also helps us to get an idea instead of a file, a particular directory, how much size is being occupied by that particular directory contents on my disk partition. So, the other way of looking at the disk space is by running the df command. So, it basically tells me not only the amount of space that has been occupied, but it also gives me how much of free space that is available for the file system. The du command will only give the space that has been occupied, but the df will also additionally give me details on a per file system basis how much has been occupied and how much is actually free space that is available. So, df is again you will find and also experience is one of the very powerful commands whenever we need to know the current status of our disk partition utilization. So, when it says that df output is like given as below, the file system that is being marked here is the partition name dev hda5, that essentially means that this is the 5th partition of my disk HDA that has been detected in my system, and /dev, as we had seen in our previous module, is basically the interface that my Unix system exposes to have all the devices exposed to the user space, right. So, my file system on /dev/hda5, the total size is 9.2 G, G here stands for gigabytes. So, the total size is 9.2 GB, out of which 7.1 GB is currently being used and what is available is 1.8 GB. So, that is basically the amount of free space that I have, and the use percentage is like around 81% is being used out of the total capacity, and the mount point is basically on the root, right. So, this particular partition, the file system that is there on this partition is mounted as my root file system right now. So, that is basically what this particular line is explaining to the user. Now, if you see the used plus the available capacity, it comes to like around 7.1 plus 1.8 GB in this particular example is only 8.9 GB, whereas the total size of the partition is mentioned as 9.2 GB. So, we will have to understand as we had seen in the file system modules earlier, some part of the file system space will be going typically for storing the metadata related to the file system, right. So, you will always find that on every system the total size that has been given for the file system will not be the complete usable capacity, but the usable capacity will be a small percentage lesser than the total available capacity. For this reason, because the small chunk of my entire file system space is actually occupied for storing the metadata related to that file system, and that space that is occupied by the metadata is not available for the end user to store his or her own data in that portion, right. So, you will always find that my used plus the available capacity in a file system is slightly lesser as compared to what is the total size of the file system that a command like a df command reports to us. Now, having looked at how much disk size a file is occupying and also looked at how much of free space my file system is having with the df command, it will possibly be time for us to do some kind of an operation to reduce the amount of disk space that our files are actually occupying in our partition. So, how do we do it? That is basically why we have the compression tools that are there. So, you have one compression tool what is called as a gzip. So, if you say gzip followed by the file name, that file will be compressed using the gzip compression algorithm, which is a standard algorithm that is actually available in a publicly known format. So, it will basically compress the file. If the compression is successful, it will create a .gz file for every file that you have given in the command line to be compressed. Once it creates a .gz file, that is a compressed file of the given file successfully, the original file will be deleted automatically by this command, right. So, all compression algorithms will basically delete the original file which was given to it, because the intent behind running a compression utility is only to save up on disk space. So, if this compression command is not going to delete the original file, what is going to happen is this compression command is going to create a new file which is the compressed file, and the original file also if it is retained. So, it is going to sort of not meet our objective of occupying reduced space, but because of the new addition of the compressed file in addition to the original file, you are going to end up occupying more space, right. So, all the compression utilities that you find, you will find automatically on a successful completion of the compression on the compression of the file, the original file that was given to the compression utility as an argument will be deleted and you will only have the compressed file, right. So, in this case if you run the gzip command, you find g and u1 in brackets here. What it essentially means is gzip is the command to compress and g unzip, right, a single word without any spaces, nothing. So, g unzip is a single command that you will use to uncompress or decompress, right. So, you have gzip followed by the file name, it will go ahead, take the file, read the file and do the compression, create the .gz file and remove this file name if it is able to successfully create the .gz file, right. And when you want to uncompress it whenever later on, if you want to process the original file, you can do an uncompression of that file by running the command called gunzip. So, gunzip is again as I was mentioning, it is just a single word. So, you just use gunzip, in short we commonly call it as a gunzip, right. Similarly, there is another compression utility called bzip2 which also does compression of the file, and the compression percentage factor in bzip2 is better as compared to the gzip algorithm. So, the gzip compression algorithm came out first and then more further enhancements to the compression algorithm was done, which had actually been subsequently got released as the bzip2 compression algorithm. So, if you want to have a better compression ratio, you can also use the bzip2 compression utility, and bzip2 compression utility will create a .bz2 file, right. Now, this .bz2 file is essentially meaning whatever is the file name that is given here. Suppose if I give kernel src as a file name, right. If the bzip2 compression is successful, it will now create a file called kernel src.bz2, right. Similarly, here if I had given that same file for gzip, it would create a file called kernel src.gz file, right. So, that is basically my compressed file. So, in addition to these two algorithms, I also have another algorithm called LZMA, which is possibly not be there by default in most of the distributions, but this is a compression tool that could optionally be downloaded and installed if we require this particular compression algorithm and compression tool, because this in the evolution is little bit better compression ratio as compared to even bzip2, right. So, for example, you will get approximately 10 to 20% more compression done with this particular LZMA compression algorithm as even compared to bzip2. For the purposes of archiving, so when do we do archiving? Whenever we come to the decision that a particular directory or a particular project is no longer going to be used, and I am going to sort of only keep referring to it very rarely, I would not want to actually consume my disk space unnecessarily for that. So, what we do is we do an archiving of that entire directory folder which is no more going to be used, and most common command that is actually used for doing this archiving on Linux is what is called as the tar command. So, the tar command actually originally stood for tape archive. So, in the olden days, whenever archiving was done, because they did not have too much of a disk space in our primary storage medium, the entire archiving would be done and the data would be actually moved into an offline tape, right. But since nowadays even the archived data is actually available as part of our primary storage medium, we will find only very rarely the tape medium being used, but historically and conventionally the tar retained its original acronym for standing for tape archive, and we basically make use of this tar command to do the archiving, where I run the command with the options of -cvf and give the archive name followed by whatever are the files or directories that needs to be archived. So, here the -c, in this C, the option C option basically stands for the instruction to the tar command to create an archive file. The V option basically stands for verbose. With this verbose option, the tar command keeps giving me details of what exactly it is trying to do whenever that archiving process is on. So, it will keep telling me that I have now taken this file and archived and next file and archived and so on and so forth, and my output will be continuously getting refreshed, right. Then the F option is basically to specify what is the archive file name that is going to be created, and the second argument that is actually mentioned here is what are the set of files or directories that needs to be archived into this archive file name. So, if you see this example, we say tar -cvf and we specify what is the file name, the archive file name that we want to have finally, and then secondly we specify what is the directory that we want to archive. So, /home is a directory that we want to archive. So, all the contents recursively under /home we want the tar command to archive and finally place it under this particular file home.tar in /backup location. So, all these absolute paths and everything we had actually seen in our previous modules. So, this home.tar file, if the tar command is successful, is going to be getting created under the /backup directory, and since this I expect this tar file to be consuming lot of disk space, I want to compress it, for example with the bzip2 command that we saw in the previous slide, and so I run the bzip2 command and then give the star file name as the file to be compressed, right. Now at the end of it, if bzip2 is successful without any errors that it is encountering, what I will end up getting is a file called home.tar.bz2 in /backup directory, right. So as we saw, seen before, the compressed file when you run the bzip2 command will be created with the .bz2 extension. So in this case, since we are giving the file name as home.tar, it will basically create a file called home.tar.bz2 in the same location of /backup. So now after having compressed, if I want to verify whether all the content that I really wanted to be archived into this tar file is available or not, I will be using the T option to the tar command. So V and F, these two options are the same behavior as what we saw in the previous slide, but the T option is basically it stands for either test or the table of contents. Now whenever we run the tar minus tvf and give the archive file name, it will list down whatever are the files that have been put inside that particular archive file that has been given as an argument. So but it will not really extract the contents from that archive. Now at some point in time in future, if for some reason we want to refer to those files in the archive and also maybe modify any of them, we need to extract those files from the archive. For that we actually make use of the -x option. So the X actually stands for extract. Similarly, we also would be using the V and F option, the reasons which we have seen with the other tar examples. So when I say tar minus xvf, X standing for extract of files, and also give this archive file name, all the individual files that were archived into this particular file will now be extracted and then placed in the current directory, right. But on the other hand, if I have an intention only to extract only few files from the archive and not the entire set of files that is available inside the archive, I could also specify, as given in this particular usage scenario, what are the exact set of files or directories that I want to be extracting alone, and in this particular scenario only those files from this archive will be extracted and not everything else. So if I use basically the GNU tar command, which is the default tar that is available on most of the GNU Linux distributions, I could also use the J or the Z option as part of my XVF to directly untar from a bzipped compression compressed file or a gzip compression file. So for example, if I basically do gtar and say -j cvf, it will now create the file that I have given here as the archive file. It will create an archive from this particular directory, do a bzip2 compression on it, and then create this file together, right. Similarly, I could also extract dynamically when I use the X option here directly from this bz2 file, instead of first doing the uncompression and then doing an extraction separately in two different commands, right. So this kind of an enhancement is actually available if I am actually trying to make use of the GNU version of the tar command, which is basically what most of the Linux distributions today is containing. So whether this option is available with your distribution or not, you could actually check up by observing the man page of the tar command, and we had actually discussed how to use the man page in one of the previous modules that we had looked at earlier. So if I want to really find out whether has there been any corruptions in the file that I am right now trying to use as compared to the original file, there is a command called md5 sum. So the md5 basically stands for a very popular data integrity algorithm called as a message digest 5, and this md5 sum command basically implements that md5 algorithm inside, which will ensure which will sort of help us to understand whether there has been any kind of corruption or modification of the file as compared to the original file, right. So the way we actually make use of it is, if you are really for example downloading a very huge file from the internet, and the original author of the that particular file who has allowed you the download will run this particular MD5 sum command and then give you the hash value that has actually been generated by this command along with the file to be downloaded. Now, after you have downloaded this huge file, in order to ensure that as part of the download over the internet no corruption or modification has actually happened, you will also be expected to run the same MD5 sum command at your end locally on the same downloaded file, and if there has been no modification or corruption that has actually happened, the output that you are getting as the output of the MD5 sum command which you are running locally on your local system should exactly match byte by byte to the MD5 sum value that the provider of that file has actually put, and if these two values match, you can very safely assume that there has been no corruption or modification of the file as part of your downloaded transfer, or if there has been a modification, you have to basically discard this downloaded file and sort of try to re-download it again with the hope that this time you will get the original file intact. So, this is basically a command that you use to ensure that the file that you have actually downloaded over the internet, especially files that are very huge in size, right, has not got accidentally corrupted or modified before you really start using that file, so that you actually end up saving up on some time wherein you will be able to detect any kind of corruption well beforehand before you actually start using the file. So, MD5 sum command is basically used for this particular purpose to check your file or the data integrity. Thank you.